Hi, this is Margo. This is Thursday afternoon, January 23rd, 2020. I hope everyone is doing well. I'm going to do a sea ice update for the Arctic and the Antarctic. Now, the last sea ice report I did was on January the 6th. So we're going to look at what's happened since then. Here is from today on Climate Reanalyzer, Thursday, January 23rd. So if we go backwards in the slideshow, we can see where we came from. So I was able to record the images from Climate Reanalyzer. Didn't miss a day this time, so we'll just go back through the slideshow and then I'll go forward as well. Now remember, they're in the middle of winter still up there. It's still dark in this area that we're seeing, although the sun is starting to come up on Iceland. I'll show you that on NASA Worldview. But all of this area is still in the dark. So here it was on January the 6th. And so I'll go a little slower and you can see mainly if things kind of fill out from day to day. There's the 8th, the 9th. We're seeing it come back out here in the Bering Sea, in the Pacific, but then it comes back in. So they had a warming trend come along there. And here it is today. So mainly what has happened, what you'll see when you see the other images, is that it was thickening. The extent wasn't doing that much. It's grown back a little bit here between Svalbard and Novaya Zemlya, but and a little bit out here in the Pacific between Alaska and Russia here, and it's come back a little bit over here by Russia, and so you'll see. This is the Navy image from today. Their website was down over the long weekend. I've seen this happen before, where it could be the person monitoring the data has a holiday, or they could be updating their system, or who knows what, but I have seen it go down on a long weekend and then it was back up on Tuesday. So here it is from today. It was red yesterday, but it's valid for today, the 23rd. I'm going to enlarge this so that we can see what's going on. Here is sea ice over here off the coast of Russia. This is part of Japan. This is Hokkaido, Japan, however you say that. I believe. I could be wrong. Then it's along the coastline. This is Kamchatka Peninsula. And then over here in the Pacific, here's the Bering Strait, the Bering Sea, and the Chukchi Sea. It's pretty thin over here. Now it was a little thicker and then it got thinner because of some warming conditions that happened. We're seeing that it's almost non-existent along the coastline here. This is part of that East Siberia ice shelf, and it's it's thin along the other coastline of Russia, and so the thickest part is down here to the north of Greenland and Canada. So right now it's in this aqua color is about 2 to 2.5 meters thick. When you go into the red is about 4.5 meters thick. Red orange. Yellow is about 3.5 to 3.75. And then the dark aqua is about 1.5 meters thick. The blue is about between 1 and 1.5 meters thick. We see the blue along here, and then the purple is below that, under 1 meter. So we've got a lot of purple up there. And we see that in the Hudson Bay, it's melted back across this western edge, this western coastline in the Hudson Bay. So we can see it's come back, it's thickened up in these tributaries up here in Canada. Now the thickest sea ice used to live along this northern edge of Canada and Greenland, but there's not very much thick sea ice anymore. Just a little bit of red here on the northern edge of Greenland, and then here's some yellow and green here on northwest Greenland, and then yellow and green right here on this island, near this island, Canada. And then there's a little bit of thicker over here along the Russian coastline. But what's happened when we're seeing the methane, the new methane data for this year, methane is coming up here. This is Severnaya Zemlya. It's spewing up here, and it's also spewing up along the northern coast of Alaska. Non-stop is what I've seen. So I don't know why that is, but that's just what we're seeing. We're also seeing it releasing out of the Chukchi Sea and coming across the Arctic in the middle of winter. Here's the 30-day animated GIF for the Navy. It goes back 3 weeks to January 1st, and then so that's the actual data for 3 weeks, and then it forecasts out for another week forward to the 30th. So we're seeing this edge just kind of morph back and forth, back and forth. That's because of this Atlantic Ocean water that's coming in is so warm. We can see here off the Siberian coastline where it is just coming up. See how, let me see if I can enlarge this while it's running. See how it melts away. So there was something that heated it up there, because the ice had come all the way up to the coastline, and then it's coming back out. It's melting away. And same thing over here. So there's that. This is a movie I made from NASA Worldview for today, and in our last show we ended with sea ice on January the 3rd, so I picked up with the 3rd and it goes through the 21st. They're a couple of days lagging on showing the sea ice data, but that's okay. So where you see the blue, it's less concentrated, so we can see as it's moving through, it was more concentrated here, and then as you go through, see the blue shade come in right there? That's where it warmed up. So we're seeing shades of blue that also reflect the thinner sea ice, like we saw on the Navy website. So there's that. Put it back to that. Next, let's go to some websites. I have everything ready. We'll come back to NASA Worldview in a minute. Here's National Snow and Ice Data Center. Here's their daily sea ice concentration. Here it is from yesterday, the 22nd. We can see that this reflects what I just showed you from NASA Worldview. The blue is less concentrated. Here's their chart for Arctic sea ice extent. Now extent is different than concentration, and the blue is this year. The dotted line is 2012. That was the lowest sea ice extent on record, and we're kind of tied. We've followed this pretty closely. We did dip quite a bit below the 2012 extent in October. Then we followed along pretty much where it was on the other months, and now we're below 20 this time for January, which would have been January 2013. So we're below that a little bit. Here on the Antarctic, here's the concentration for today. For yesterday. And it's melting because it's their summertime, and they're still in full sunlight down there. And this is the Ross Sea. We can see that it's melted all around the edges of the continent, and this is the sea ice that's left over here. Now traditionally the sea ice around the Antarctic does melt pretty much during their summer, and then it refreezes. It's a lot different than the Arctic sea ice. They just behave differently. First of all, the Antarctic, the sea ice is around a continent, whereas in the Arctic, the sea ice is in the center, surrounded by landmass. So that's a huge difference. And also a lot of the Arctic water is fresh water. It used to be, now it's mixing. So you just have different qualities. And so this is seawater that's freezing or melting now. Here's their chart for Antarctic sea ice extent. The lowest was last year, this gray line, and we had gotten below that back in November and December, and then it crossed above it, and it's still above it. And So that's where we're at with that. It's still low, but it's above the lowest. I want to go over to the Navy website, and here's the Arctic view with all the different things that you can see. But I want to show there's some other things that you can see. You can see the Beaufort Sea. If you want to look at that in detail, you can see the sea ice thickness here. And this is Alaska. So the Beaufort Sea is on this northern edge of Alaska going out into the Arctic. So you can see this is where the thickest sea ice is in the Arctic, and you can see it more in detail there. So it's a little easier. So that's the thickness. Here's the strength, ice strength. And these blue lines are where the sea ice is melted. It's called leads. A lead in the sea ice where it's kind of cracked and broken up, and then the lead refreezes. And this is one of the leads too, here, going all the way down. That's why it's in this purple and in the white, so it's not strong there where it refroze, where it's, because that's thin where it cracked. There's an, oh, I wanted to show something else. They actually show you ice opening. This shows the leads. It's the lead area opening rate % per day. And I just learned about leads recently, and so this is where the sea ice comes apart and opens up, and then it can be fresh water underneath there, or it can refreeze. And when it opens up, it affects the atmosphere. It affects the clouds. And of course, when the sun's shining, when it opens up, then it heats up the water faster, and so that means the ice will melt faster too. You can see the GIF. This is the 30-day GIF where you can see the openings move around. So this is in that Beaufort Sea area. So I think it's pretty fascinating to see the movement. This is how the ice is moving and shifting even in the dark that we're not aware of. So there's a lot of activity going on up there. So I wanted to show you that. That's under ice opening, and this is in the Beaufort if you want to check that out. And then you can look at the Antarctic, and they've got, we can see the sea ice thickness here, and we can blow it up a little bit. And just like in the Arctic, we can see the purple is pretty thin all around. And there's the thickest ice. There's a little bit left here in the Ross Sea, and then on the northern edge, and then over here off in the Weddell Sea, this is part of the Larsen area, and then over here on the western peninsula, or western side. And then you can see their 30-day animation. This is you can actually see the melting. It's really going fast. You can see it. It's amazing to watch that. Blow it up a little. And on Climate Reanalyzer, the Antarctic is warm, much warmer than normal. So it's all melting faster. Another thing you can look at is the Ross Sea, which is part of the Antarctic. And this is important because there's an ice shelf there. Here's the sea ice thickness. So we can see there's nothing there. This is the ice shelf here, I believe. I could be wrong. But it's just a little bit of thick, but you know, that's thicker than what we saw in the Arctic. Okay, let me stand corrected. The ice shelf is along up here, I think. So, anyway, you can look at these things if you want to see. This is what's happened in the last 30 days in the Ross Sea. And you can see the melting quite a bit right at the very end of the animation here. And here's the ice opening down here. This is the leads and the openings. We can look at NASA Worldview and get a better idea. So what we're looking at, okay, so here's the ice shelf, here's the opening, and we're looking at, there's some sea ice right over here. It's pretty cloudy. Let's see if we can get day without the clouds. Hard to get a day where we can separate the clouds from that, but the sea ice that we're looking at is right down here. But this is the ice shelf, so they're counting that. Then where was I? The ice shelf is down here. So there are the leads, the openings. So if you want to watch that, here's the 30-day. Now you have to have ice for the openings to appear in. This is the melted area. That's why you're not seeing the white. You're not seeing anything in the white there because there's no ice there. So I thought that was kind of interesting. So if you enter from polar oceans, you have all those choices there. Now, let's take a peek at NASA Worldview a little better. The first thing I'm really kind of flipping out about is this iceberg A68. Look at it. So we were on January the 6th the last time. Look at where it was on the 6th. Now we're looking through clouds. It was further south, and it was rotated about to the 1 o'clock position. Now watch it. Watch it. Okay, you can get a good view of it here. Now here's the Western Peninsula, so that we're using that as a reference point. There's a good view of it, of the 11th. And look, it's melted in. That used to be solid there. But it's broken away from the other sea ice. It's totally by itself. It's independent. Look at this image, and it started now to rotate counterclockwise. Watch this. There was a big shift. Did you see that? Now it's almost straight up and down. There's the 21st. Look at the ripples. Now it's left the 12 o'clock position and moving on to the counterclockwise. And here it is today. Another big shift from yesterday. See? So it's really taken off. No one's talking about it. I don't know what's going on there. Another area I'm watching over here is on this Amory ice sheet, this A28 iceberg that broke off. It's in this mass of ice that's separated from the coastline, and it's moving out. It's hard to see. Here it is. There's a good view of it. This is it. Right here. It broke away. It was down here. So that's still bound up in all this ice, but it's all moving out now. Here's the 23rd today. And another area I'm watching closely is this Pine Island Glacier. It is calving. You can see several lines where it's cracked. These are cracks all the way across. And so that is going to break off. I don't know how soon, but it's definitely calving. That's going to be a huge, huge area that breaks off. So there's an active volcano underneath there that's keeping that heated up. So there's the Antarctic. Let's look at the Arctic now. I wanted to show you. This black circle is starting to get smaller. The Earth is starting to tilt back. The North Pole is starting to tilt back towards the sun a little bit. Slowly. We can see that Iceland is all in sunlight now. And Greenland, that's going to be getting some more sunlight. Norway is getting a little more sunlight. Here's the Kola Peninsula. This is Russia. It's just on the tippy edge of getting some more sunlight. Here's Norilsk in Russia is right down here. They're in the sun now. That's the toxic city. This is all still in the dark. Here's Novaya Zemlya, the Kara Sea. This is Severnaya Zemlya. This is where the methane is spewing up. This is the island that has the 5 glacier caps on it that are melting. Here's your Laptev Sea. Here's the Chukchi Sea. And here's the northern edge of Alaska that's still in the dark, and there's a lot of methane coming up along this northern edge. This is the Beaufort Sea that we were seeing. So we'll be watching as the sun starts coming up to see what's going on over here. This is just data they haven't gotten in yet. Let me refresh. There. Now we can see. That's what that looks like. Let's look at it from yesterday. So this is where the sun is coming across. So the Bering Strait is now in the sunlight. We can see a little bit of sea ice through there. That looks mainly cloudy though. Hard to make anything out there. Here we can see sea ice. This is what it looks like off the coast of Russia there. Now, I have a report for you today. This is from the Polar Science Center. PIOMAS, Arctic Sea Ice Volume Reanalysis. They have their annual update for the Arctic sea ice. Let's look at this. It says annual update 2019 finished with an annually averaged sea ice volume that was the second lowest on record, with 13,500 cubic kilometers, about 600 cubic kilometers above the 2017 record, with the very similar volume numbers for recent low annual volume years of 2011, 2012, 2016, and 2017. So it's second lowest on record. So here's their chart. And we can see the blue line is showing the general trend. So even though some years it might be up a little bit, the general trend is downward. And this is the sea ice volume. That's where they add it all up together. The thick and the thin, and makes all the volume. And that's what's the most important thing, is the volume. December monthly update. Average Arctic sea ice volume in December 2019 was 12,500 cubic kilometers. This value is 400 cubic kilometers above the record value of 12,100 cubic kilometers set in 2012, making it the second lowest on record. Monthly sea ice volume was 52% below the maximum in 1979 and 37% below the mean value for 1979 to 2018. December 2019 ice volume falls 0.2 standard deviations above the trend line. Daily volume anomalies for December show relatively normal ice growth rates, but since the growth season started at near record levels, 2019 winds up the second lowest ice volume overall for that month. Average ice thickness is in the middle of the pack for the more recent years. Ice thickness anomalies for December relative to 2011 to 2018 show positive anomalies in a band reaching from the eastern Beaufort across the central Arctic, while negative sea ice thickness anomalies dominate elsewhere throughout the Arctic. Deepest negative anomalies appear along the Canadian archipelago and north of Greenland. December ice thickness anomalies from PIOMAS agree well with Cryosat-2 data from the Alfred Wegener Institute excerpt for an area extending from the eastern Beaufort into the central Arctic, where PIOMAS has neutral anomalies while Cryosat-2 shows positive ones. Interestingly, the Cryosat and PIOMAS showed nearly opposite anomaly patterns during April before Cryosat went into its annual summer hiatus. Time series of November ice volume for PIOMAS and Cryosat-2 agree well, underscoring the accuracy of the PIOMAS modeling system and providing support for the validity of the PIOMAS 40-year trend. Updates will be generated at approximately 1-month intervals. So here's this graph. This is the daily Arctic ice volume. So the red is 2019 so ends in December. So we can see it's right down close to the bottom, not quite at the bottom, but for some month it was at the bottom. August, and so on. Here's Arctic sea ice volume for April to September. See, it's trending down. April is blue. September. April trends were minus 2.7. And September trends were minus 3.2. So this might be in a website that if you're not familiar with it, you can look at it. He has a lot of graphs and stuff. Talks about the model, validation, and he shows a lot of different things. Here's the Cryosat-2 image for sea ice thickness anomaly for December 2019. So these blue areas are where it's thinner than normal, and the brown areas is where it's a little bit thicker than normal. The thickness anomaly. And so on. So that's my report for today. I'll go ahead and sign off. And I wanted to show you one more thing. On earthquakes, we've had some Arctic earthquakes, and I think the earthquakes definitely have a bearing on the sea ice. We're seeing one that happened right up here north of Svalbard, that was a 4.7 that happened today. Here's one south of Svalbard. This was a 4.4. We've had 31 right here in the Aleutian Islands at the Tanaga volcano. 31 here in the last 24 hours, including a 6.2. This is a dormant volcano, but I'm thinking it could come back to life. The 6.2 happened at last night at 9:51 Pacific time. So all of these, 31 right there. And the last one came in at 5:28 this morning of 4.3. And these aren't small. I mean, there's some 2s in there, but a lot of 4s, mainly 4s, some 4s, but the 6.2 was the second one. The first one was this 2.2, and then the 6.2 just boom, just rocked it. I'm not going to do a whole earthquake report here, but I want to show, let's look, 7-day all magnitudes. I'm going to show you just in the Arctic what's going on. Okay, so there are those two. So that one right up there is very near the North Pole. Then down here there were two that USGS picked up off the coast of Iceland. There were 10 according to EMSC. They were lower than, they were under 4 magnitude. They were in the 3s range. So that's why the 8 of them didn't get picked up. So 10 total right here all on the same day. That was on the 18th. Then, of course, Alaska is very active. Very, very, very active. Look at all of these coming down here. And then here are the Aleutian Islands, and here's the Tanaga volcano. Oops, too close. And so this whole area right around this, the Tanaga, has had 196 in the last week. And remember, there was a whole bunch up here in Russia, oh, I don't know, a week or two ago. There was another one of 4.1 here, then some more here off the Kamchatka Peninsula, good size 5.6, and so on. So that's mainly what I wanted to show. But also near the Antarctic, we've had some more on this southern ridge. Now remember, this is the Western Peninsula. Right here is the A68 iceberg coming out, and here are 2 more earthquakes of 6.1 and a 5.2. These have happened recently, and that's happened yesterday, the 22nd, both of those. And I did the report on the sulfur dioxide and showing the releases of sulfur dioxide and showing that I felt like the plates were moving down there. So that one, the 6.1 was 91 kilometers deep. The 5.2 was 35. Now, when you see them, when they say 10 kilometers, that's the default reading. That if they don't know how deep it is, or they don't want to say, they just default it to 10 kilometers. So don't think that all of the earthquakes and thousands of earthquakes are all at 10 kilometers deep. They're not. So I'm going to go ahead and sign off for this recording of the Arctic sea ice and Antarctic sea ice. So if you appreciate my work and would like to donate to the cause, I have a PayPal link below. I would really appreciate any donations or support. I am not monetized on YouTube, and I probably never will be. And so I just do this. This is what I do. So the PayPal link is below, and I appreciate the people who have donated. And if you'd like to follow my work more closely, you can subscribe to my Subscribestar page, and that's $5 a month. You can get all the updates that I'm posting almost every day, and definitely posting the methane data from CAMS every time it comes out. And that's over for my members on Subscribestar, and you can also donate over there too as a member. And I appreciate all of my Subscribestar members, and I appreciate all my YouTube subscribers. And be sure to give this video a thumbs up if you like it, and subscribe and hit the notification button. And I do believe we are in the end times, and no one knows the day or the hour. But by looking at all of these signs and what's going on, in the world, and I've chosen to stick to reporting data rather than getting into a lot of social discussion and things like that. You can get that on other channels, but I like reporting the data. But you can see from the data and from what's going on in the world, things are ramping up. And I think we're getting that much closer to the end, that much faster. And if you haven't done so already, I recommend that you give your life to Jesus Christ and get right with God and Jesus, because I do believe the end is near. So I love you guys, and I'm praying for everybody. So until next time, God bless you, and go in peace.